Okay, now let me introduce an old friend of Incontro DevOps, Giulio Vian, that already gave presentation here a couple of times before this, if I remember correctly. Okay, so Giulio is a software engineering with a strong experience on production environment, and his focus is Microsoft, let's say, even if it is not really Microsoft today, but it always worked on Microsoft stuff. It currently works at Unum, helping teams in digital transformation initiative. It's a speaker at international conference, and it has been awarded Microsoft Most Valuable Professional on Azure for the last 5 years. And today it is speaking about how to write cloud-agnostic Terraform code. So really interested in that. Giulio, you have the stage. Let's see your contribution, and then we will be back with Q&A after you give us the go. Do you have anything to say about the introduction to your talk?
No. I'm always been a bit of a black sheep, you know. Really well connected with Microsoft, but I have my own ideas. So, and I like a lot this new Microsoft with the Nadella at helm, and they're opening because a lot of people is happy with that.
Okay, let's now move to Terraform code.
Yep.
Okay.
Good afternoon, everyone. Thanks for your time to attend this session. We will explore how to abstract our Terraform code from being provider-specific and how to leverage a few cool features of Terraform 0.12 and 0.13. So, even if you're not interested in technological agnosticism, you might enjoy a practical example of the latest Terraform abilities. All the code will be publicly available on GitHub. Truly, it's already available. So, why this session? It happened that I was involved in a customer project and the customer insisted on using 2 different cloud vendors. A major one, but they were different. This is a common request from big customers. They do not want to put all their eggs in the same basket. Studying the 2 vendors' documentation, one was already well known for me, the other one was less known, but I knew Terraform well, and I was thinking, well, instead of writing everything from scratch, maybe we have something in common between those 2 vendors. And so I made up a proof of concept where I demonstrated the ability to build the same infrastructure on either platforms. So I worked it out in the end that, like most customers, the management is really uncomfortable with the multi-cloud concept per se. They really opt for a multi-vendor strategy, which means that they put different workloads on different cloud providers instead of wanting that they can put the same workload on either provider. Anyway, I think that the consulting business is very interested in portability and having a common code base, abstracting from the cloud provider vendor, and they want to have their solution on all clouds from all major providers. So, by preparing this session, I choose to focus specifically on AWS and Azure because they are the most common cloud provider that you find outside. The customer was really opting for GCP, but I think that this audience will be more interested in AWS. Before we move on, there is a couple of important assumptions that we have to be very clear about. The first one is that I assume that you know the basics of Terraform. I assume that I don't have to explain the code and explain the basics. I will highlight some interesting pieces about Terraform 12 and Terraform 13. Yes. And I hope that in the end you will discover that different providers in Terraform, when they relate about cloud technology, they are more similar than different. The other assumption is that we will require to use Terraform 13 or above. Okay, the code will not work with earlier versions. So let's take a look at some examples. The AWS code to allocate a virtual machine using Terraform is very specific for the AWS context. In fact, you allocate an AWS instance, all right, as a resource, and the fundamental properties are which operating system image you want to use. Could be a bare-bone Linux, or a full-fledged Oracle instance, or even a custom image that you build up yourself. The computing resources that will power this virtual machine in terms of CPU, RAM, GPUs, networking, hardware, special configuration, whatever you need. Yet another element, you see how the virtual machine is connected to the network. So you specify the subnet where the machine is connected to, and so on. Last, not less important, is the machine identifier. As AWS generates the machine identifier, you must absolutely specify a special tag with name as the key to give the virtual machine a name, and be able to easily find it in your console or in the CLI. So let's look how the same code is in Azure. So here we have a comparison between the two. In Azure, you still use a virtual machine resource. The name is a bit longer, Azure RAM Linux Virtual Machine, but there are some important differences. For example, the region where the machine is to be created is an explicit parameter. In AWS, this is instead tied to the provider configuration. In Azure, the OS image is identified using the 4 keys instead of using a single AMI identifier. Also, the networking is specified in a different way because Azure has a separate resource to describe the networking, while in AWS it's just a bunch of properties of the instance. Finally, the Azure providers require some settings which are taken by default in AWS. So, for example, we specify the performance of the disk attached to the virtual machine. Okay, we've seen some general concepts are there, but the code is different. How we are able to generalize this code? We can solve any problem by introducing an extra level of indirection, they say. I don't think it's really surprising, this approach. How it works in practice? We abstract the differences between Terraform providers using Terraform modules. So far, so good. The module parameters should be provider neutral and within the module translated to provider-specific values and formats. It's important to pick the right abstractions so that we end up with a rich model where we can define a great deal of details and can combine simple components in complex ways. My recommendation is go through a top-down approach. Let's see. A top-down approach starts by looking at the overall architecture of our systems and moves down to finer graded components. The diagram illustrates my personal choice for decomposing a system. The global block contains cross-cutting services like AIM in AWS, AAD in Azure, that is, the security, the users, the groups, the permissions. Also, any networking that is required to connect resources across regions. This is typically for a disaster recovery scenario, which will be an important requirement in enterprise scenarios. If you drill down within a region, zoom in, you have a segment, and the segment is an abstract concept for an application. An application that lives in a distinct part of the network. A segment may also be used to represent availability zone or similar constructs. A data block, zooming into the segment, can be an S3 bucket in AWS, or an Azure storage, blob storage, or could be an RDS in Amazon, or an Azure database instance, like a SQL instance, whatever you need for your data storage requirements. If you look up, Microsoft even has a couple of pages that maps AWS and GCP services to the Azure equivalent, and this can be useful also for going from AWS to GCP and so on and so forth. You will see the link in the at the end. Now, note that you need to abstract not every possible components, but the one that gives you the most benefits. So probably 80% of the component should be abstracted, the one that you use most, that are used again and again. But there are other components you just can create using more provider-specific code or manually through the console or through the CLI, whatever, like complex network infrastructure like express route in Azure or direct routing in AWS that is interconnecting your private network with the cloud networking. That can be set up once for all and later plugged into the abstract modules that are provider agnostic. So be pragmatic in this respect. Also, Terraform data sources are very helpful in decoupling modules and abstracting resources. They are a great resource. In the past, they weren't so rich and so useful, but now they are a great way of avoiding passing parameters from module to modules. In general, the goal is that you end up with the code that can move from one provider to another with a minimal effort. Okay, let's see a few more details before we go into the code. If we zoom in, a thing like a computing block, this is just an example of how you can decompose a system. It abstracts not just the computing resources, but also the networking that is tied to those. Because typically, you have something like a load balancer that's required if you use the auto-scaling in AWS or the VM scale set in Azure. For example, you will need to specify which port must be open to reach your application. And that is also part of the computing block. It shouldn't be external to that. This abstract block can be further specified to be a serverless resource or a container or a VM. That's enough for abstraction and designing and decomposing. Let's see some concrete example and go into the demo code. One caveat, this is not a full-blown framework of abstract code. It just demonstrates how you can allocate a virtual machine using the same code in either AWS or Azure. And with this, we switch to the demo code. This is the sample Terraform repository, which is available in GitHub. We will see the link later. We look at the agnostic modules directory. Here we have two files, main and version TF. The latter is a new requirement, or a new convention to be precise, from Terraform 013 that wants to have all the provider configuration or provider requirements, to be precise, in their own file named with this conventional name. In this case, we only use Terraform, no providers at all, and we require the latest version of Terraform 013. Truly, 014 is just out. In the main file, what we see is the invocation of 3 times the same agnostic application block module. The first one will create a virtual machine in AWS in the Ireland data center and will be a Windows Server 2019. The second invocation will be, again, agnostic application module block and will be in the England data centers, this time a Linux Ubuntu server. The third invocation will be on Azure, in Azure Island data center, clearly, and also a Linux virtual machine. So a few interesting things here. There is a quality of service object that describes what we want for this virtual machine in terms of performance, security, load balancing, configuration, and so on. This is graded from 1 to 5, with the 5 being the lowest and 1 being the highest. The location is pretty clear. Section is the only interesting thing because we imagine to have a different module that creates the section with all the networking and subnets and whatever is required there for a specific application. In addition, we have the tags, which are kind of pretty normal requirements. So this is the main module, you see, nothing specific for a provider. Under modules, we have the first layer, which is the agnostic part of it. And we have quite a few elements. Again, we have the versions TF. This time, we have something, because in addition to require 0.13 for Terraform, we require AWS and Azure. For AWS, you see that we have to specify the region because that's the way how the AWS provider works. And it's calculated from the parameters. You see var location geography matches what you've seen before here, location geography. Let's take a look at the variables. You see that they matches the parameter we were passing. A couple of interesting things. We use a lot the object, so we don't use 20 different parameters, but we try to group them logically in a more meaningful way and easy to understand and look up. In addition, we use the new validation clause that is available for variables in Terraform 0.13, where you can restrict the values and check if they are matching your rules. So it could be, like in this case, could be a simple matching inside a list, or could be something more complicated like a Boolean expression. Let's look at the main part of this abstract module. You see, we simplify our code by computing a number of locals, temporary variables from the input parameters. Those are looking up into some tables, which are defined in this configuration data file. We will get there in a moment. You see that for abstracting a virtual machine, we have the invocation of a specific provider-specific module, one for AWS and one for Azure. The trick is we use the count variable to say this module has to be instantiated or not. So we have a 1 or a 0 depending on the past variables. You see, and we look at the location cloud to determine if this module has to be instantiated or not. And we pass to the module some decoded values for the main information. Crucial here, we are forwarding the provider configuration for this module. That's why we need to kind of pre-allocate all the modules in the agnostic level for all the providers we intend to use in our module-specific code. Let's take a look at the configuration data. Those are simply maps that decode what we said in abstract. So, for example, the island data center for AWS maps to the EU West 1 key, while for England it's EU West 2. In Azure, the island abstract value maps to North Europe, and for England maps to UK South. Clearly, you can use different values, have many more regions, but that's the basic idea. Similar for the section. The section, we need to map the virtual machine to a specific subnet that we suppose existing. And for example, If we go to the virtual machine images, we were using some very abstract term like Windows Server 2019, and this will map to a search expression to use in Amazon. While, for example, for Azure, this maps to the 4 keys we have seen before that are required for specifying an Azure image, and so on and so forth. Similarly, the performance is decoded to a size of a virtual machine instance. And you see the difference between AWS. I don't have a lot to play with AWS with a free account, while I have much more option here in Azure just because I have a richer subscription and I can allocate bigger stuff. So we have seen the agnostic module. Let's take a look at the specific modules. They are kind of very simple, very straightforward code, the one that you're used to see. Again, we have the version. In this case, we don't restrict much because we just require the Terraform, and for Azure Resource Manager, we required a specific version for us, which is pretty new to 2019, recent. The parameters are pretty straightforward, pretty simple, and in the main, you will see that we use a lot the data, in this case, for looking up the resource group and the subnet, which are 2 required information to allocate any resource in Azure. And you see that the specific model is allocating both a network interface and a virtual machine. In this case, we opted for a more generic virtual machine because it's more convenient as we want to switch between Windows and Linux easily. And there is some additional tricks, like, for example, the use of a dynamic properties. So when we are creating a Windows virtual machine, this will be instantiated, while this one will instantiate this other property when it's a Linux virtual machine. What else? There's another quirk. For example, the name for the Windows machine can be longer than 15 characters. I mean the computer name, not the name that you see in the portal or in the DNS. And one last trick, you probably are very used to that. We merge some specific tag that we compute at this level with the tags that were asked for in the top main module. The AWS module is pretty similar. So we have again a version, and we required a most recent version of the AWS provider. And in the main module, again, we use the data query to find the subnet and to find the AMI that is matching the regular expression that we specified before. So we don't have to hard code the AMI key in our code. And again, the merging of tags is a little more complex because we encode also the region and the name, which is something you get for free in or in a different way in Azure, and everything else that is required. So Windows, you pick up the Windows or the Linux AMI, and the subnet is the one that we found. And this is the basic idea around the code. Summarizing, we have a top level, which is completely agnostic, pretty neutral. You use very abstract values. And then you have a module that will translate to something more specific, especially decoding all the keys that you want to pass down to the provider-specific module. At this level, you need to define the provider configuration, so which region for AWS, for example, or some other quirks that you have for Azure or Resource Manager provider. And then you have a specific module. Clear, you may have everything here, but typically you will reuse some ready-to-use module or module that you developed in the past. Now let's take a look how it works live. Now we see the Azure portal has already a resource group in the North Europe region, which means Ireland. this resource group holds just one virtual network for our applications, for our virtual machines. In the AWS console, in the Ireland region, we don't have any instances, but we have a VPC that is ready for our virtual machine to use. The virtual machine has the same name that we saw in Azure Portal for consistencies, and in the London region, again, we don't have any virtual machine, but we prepared a VPC with the same name as the others, just a different subnet. And that's the situation before we run Terraform and create the new virtual machines. This terminal is already positioned on the sample directory. I already defined the environment variables with the AWS and the Azure credentials, so we run Terraform init. It downloads and configures all the providers for both clouds. The next step is to run Terraform plan. So let's do it and save the outcome in a file named _plan. That's my usual convention. It will take some time, so we speeded up the recording so you don't have to wait for everything to happen. Let's zoom the window and see what Terraform is thinking to do in the plan. There are a few interesting things. For example, we have a virtual machine for AWS here, which is with the supposed name of 123 Windows in Ireland, EU West. And we have a network interface for Azure Virtual Machine in its own resource group, and the Azure Virtual Machine 2, which is a Linux virtual machine, and the size of the virtual machine is D16v4, which is kind of pretty beefy machine. And also, finally, the third machine in AWS, which is a T3 Micro, and this one is Linux. It's not a Windows machine. But this one is in EU West 2, which is UK. Or to be precise, London. After this, we run the Terraform apply against the plan that was just computed. As we did before, we speed up the recording so you don't have to wait for the 2 or 3 minutes that takes to create all the 3 virtual machines and related resources. Now we switch to the portals and see what we have there, what has been created. In AWS, we see in London that clearly the network hasn't changed. So we go back to the virtual machine instances, the EC2 page, and we see that we now have one instances for London with the Linux virtual machine 1234, which is a T3 Micro as expected. In Ireland, we also have a virtual machine, and it's 123 Windows virtual machine, it's T2 Micro. In Azure, same, we refresh everything, and in this resource group, we will see the new Linux virtual machine with the disk and the network card that is associated with that. If we zoom into the virtual machine, we can easily see that has the requested size and operating system. And this wraps up our demo. We have seen how to abstract from provider-specific code and also some interesting new Terraform features. Let's review this later quickly. Terraform 013 offers you the count zero argument, which can be used with modules, and this is, in my opinion, one of the best new features we have with 013. Also, you learned that we can use objects. They are a prime type and can reduce the number of module parameters and simplify your code. Variables can now be checked before usage, and you can get a meaningful error message when required. Finally, the region of the AWS provider can be an expression calculated dynamically, and you can pass this provider configuration to submodules, which is a great thing. Terraform data sources are a great way to simplify your modules, reduce coupling, and the number of input-output parameters. Here, it's a bunch of, hopefully, useful links. The first link is the Terraform documentation. The second links to the Terraform book, which is the best known. And now, if you bought the first edition, it's time to buy the new one, which covers Terraform 0.12 and all the great changes that they made. Then there are a couple of links to Microsoft pages, which list side by side the equivalent AWS or GCP service. The last to final is the link to the repository with the sample code and the link to my SlideShare account where I always save the presentation, so you can see it later. Some information about yours truly. I started with poor hardware when writing assembly code was not an exceptional thing. I worked for quite a few companies over the years in a few different roles. Now I work for Unum, which is a Fortune 500 insurance company in USA. I'm being recognized by Microsoft with the Most Valuable Professional Award in the last 5 years, and I like to help communities throughout Europe. My references, where you can contact me, an email, on Twitter, or in one of the few sites where you can find me. See you soon.
Of questions for you just now. I can always see the value of writing portable code, but as you have shown us, it takes discipline and extra effort to write portable code in Terraform. So, in your opinion, what's when one really needs to write, make this extra effort and write agnostic Terraform scripts? I mean, do you have any special use case in mind?
Well, I think this is most interesting for consulting companies or companies doing services, so they can move toward their customer. If the customer wants to go to Amazon, they can say yes. If a customer wants to go to Microsoft, they can say yes. If a customer wants to go to Google, they can approach that. So I think that is the kind of business that is most interested in agnostic code. Could be also interesting for some major enterprise customer, you know, kind of global Fortune 500s, people that don't want to put all their eggs in one basket. And so they want to be able to, with a reasonable effort, move their workload from one vendor to another vendor. I think those are the most common scenario. If you're working in a small company or a startup, I think it's more efficient to just go in with one cloud provider because you need to acquire the experience on how it works, the many APIs, all the quirks that a cloud provider offers you, because there are a lot. Why the heck you need things in that provider and you don't need in the other one? Yeah, you need to learn. That said, it's always a good thing to do some planning of your Terraform code. Yuri had a good insights in his book in how to decompose the entire thing, your entire system in layers and blocks and networks. I tried to hint at that in the presentation. And modularizing is very important anyway. And think long term, what is the most stable things in your infrastructure and what is kind of more volatile. Virtual machine that can be destroyed easily. Networking is a lot more complex to change after you laid it down and you need to move stuff.
Okay. Starting from your example about the startup. So suppose startup begins working in one of these major cloud provider, either one and so it really builds its own Terraform instruction set specification. Really focusing on that cloud, then it becomes, it scales, it becomes more important, and it has the need to go multi-cloud. So, in your experience, what are the most common gotcha that you encounter moving from a single cloud to multi-cloud, and obviously related to Terraform code?
Well, one of the things is security, because there are, if you stick to kind of infrastructure as code, virtual machine network, it's quite easy to map what a cloud provider offers with another one. What really gets a headache is security, because they tend to have a different approach to manage security. Because, for example, Azure is very hierarchical. You have a lot of different constructs to easily set things at the top and have them ripple down in lower level objects. While you have a lot of fine control, but you need to build up similar higher grade objects in AWS. That's my experience. So regarding the code itself, it's more you need to properly manage the state, because you will need to refactor your code to abstract what you have done in one provider to be more generic and move to another one. And every change will impact the names you have used, the identifiers. And so you need to be very, very careful with the state when you start to apply the thing, because just refactoring the code is the easy part. Applying the changed code is the nightmare. Can be done, but recommend a very step-by-step, commit-by-commit, line-by-line change, because it's easy to screw up. It's very easy to screw up. Require a lot of discipline. Yes.
Yeah, Terraform can be a quite scary object if not used properly.
Yeah, you need to know your baby. Yes, but it can be done. It's surprisingly flexible. Yes, absolutely. But need to know it very well, to experiment a lot and know very well how the state works. That's kind of the most scary thing of it all.
Okay, I don't see any other questions in the chat, so thank you, Giulio, and hope to see you again in the future.
Me too, Ivan. Always a pleasure to be with you and your teams.
Okay,
Yeah.
bye.
Yep. Ciao, ciao.